Hello, this is a question about the Stefan Boltzmann law, which states that the power of a star is a constant times the area times temperature to the 4. Now they tell us that the two stars have the same surface temperature, so we could write something like this, and then by rearranging for the temperature we could have an expression for the power and the area on both sides. But I want to look at it in a slightly different way. Hopefully this will be more intuitive. It's a little bit more abstract to begin with, but then I hope it works much quicker. And anyway, let's give it a go. So we want to know the luminosity. So I'm going to find out how that depends on other things. I'm going to ignore the constant. The pressure goes like it's proportional to the area times temperature to the power 4. Now they've told me that the temperatures of the stars are the same, so I don't even need that in my equation. The pressure simply is proportional to the area of the star. They're telling me what happens to the diameter, and I know that the area goes like the square of the diameter. And looking at what happens from x to y, x has a diameter 4% greater, so the diameter gets smaller from x to y, and therefore the pressure, because it's proportional to the diameter squared, we'll divide that by 1.04 squared. So you do 8 times 10 to the 26 divided by 1.04 squared, and that gives you 7.4 times 10 to the 26. Thinking about it, x is bigger than y, and given that they're the same surface temperature, that would mean that x would produce more power than y, so we would expect a smaller number.